will extend the concept of the Laplace transform based on this topic. Now write down the topic of Laplace transform. We have write down the topic. Now we have to come into that topic. Now write down the if ft and f dash t is piecewise one piecewise continuous, then Laplace transform of f dash t will be 0 to, let's say, e est st f of t dt plus a1 to a2 est f dash t dt dot dot n minus n to infinity est f of t dt. Okay, that is our theorem. You can prove it easily. Okay, there is nothing I have to show you. Now next, I am writing down the Laplace transform of nth derivative of a function f n t is given by Laplace transform of f n t equal to Sn f of t minus Sn minus 1 f of 0 dot dot Sn minus 2 f of 0 dot dot S f double dash n minus 1 f of 0 minus f of n minus 1 f of 0. That is our Laplace transform of derivative. If you can prove it, if proof you can write it. Proof if n equal to 1 by PMI, you can prove it. Okay, PMI n equal to 1, we get Laplace transform of f1 t equal to s f of t. Okay, here that will be 0, so that give us f of 0. So which is true? Okay, which is true? Which is the derivative of, we have seen derivative of the function f of t. So now it is true for n equal to k. Then we find that Laplace transform of f of k f of t equal to sk f of t minus sk minus 1 f of 0 minus sk minus 2 dot dot s f of k minus 1. After that you can prove it. You can replace it k by k plus 1. So here I am erasing it. So you can replace k by k plus 1. You get Laplace transform of k plus 1 f of t will be what? You will multiply this. Okay, that is given Laplace transform of f of k. Okay, t into Laplace transform of f of t. After that you get now suppose let gk equal to f of k plus 1. Okay, then Laplace transform of g dash k is what? S f of gk minus g dash. Okay, there is nothing have to worry. After that g dash. Now you can replace it by what we have by 4 and 5. We can get it the answer. So there is nothing only. Now I am going to do the solve the more problem on the Laplace transform. So write down the question. Now I have a question. So find the we have a function. What? Write down the question. We find f of t and f dash t, where ft is given by 2t, t greater than 0 less than 1. Okay, as and t greater than 0. Okay, we have to find a Laplace transform of f of t and Laplace transform of f of dash t. Okay, how can we do this? So we know that Laplace transform of f of t is nothing but 0 to infinity est f of t dt. Okay, so that gives me limit b tend to infinity 0 to b est f of t dt. Now that can be written as limit b tend to infinity 0 to 1 est f of t dt plus 1 to infinity f of t est. Okay, dt. Now we have a function limit b tend to infinity 0 to 1 est. Here function is 2t. Okay, 2t dt. Now here 1 into infinity ft is what? T est dt. Okay, here 2 will be outside. There is no other thing. B tend to infinity 0 to 1 est t dt plus 1 to infinity t est dt. So after integration it gives us limit b tend to infinity est. Okay, est upon minus st t plus 1 by s. Okay, so 1 to 0 to 1 plus similarly it gives us est upon s t plus est upon s 1 to b, where b tend to infinity. After putting, you guys can find the derivative of a function. Now we have a derivative. We have to find a Laplace transform of f dash. So after that you can find Laplace transform of f dash t is what is nothing but s f of t minus f of 0. Okay, that is the derivative. You can use it. So easily you can find the derivative of the function. So or you can use this as a function. You can easily find it. Now I am writing the next question. Or you can easily find it if you do not want to wish it. So we can write it. So what Laplace transform of f dash t is what we know 0 to 1 est f dash t. Okay, plus 1 to b est f dash f dash t dt. What is the derivative of f dash t? 1 est upon 2. Okay, dt plus b tend to infinity limit b tend to infinity 0 to 1 to b est dt. So we get 2 est by s 0 to 1 plus est minus s 1 to b, where b limit b tend to infinity. Putting t 1 instead of t, we get 2 es upon s minus, that give us plus 1 by s. Similarly, when b will be infinity, that will give us 0. So when it's 0, it gives us 1 by s. So after that you can find it, there is nothing. So we have done the question. Now you can make it easy. You can do the solve the problem. I hope you have able to understand it, how to find the Laplace transform. Now we are going to know the concept of we are going to expand. You can find a Laplace transform, prove it. Laplace transform sin a t is given by a s square plus s square. Okay, find L F cos a t. Okay, you can easily prove it. There is nothing worry. First, what we'll do? Use the I am giving the some consequences of the n derivative of a function. So write down the consequence of Laplace transform of f double dash t is equal to s f of t, okay, minus f dash 0 double dash. So how to remember it? So you can here, this is the derivative of second order. Here we know f of n t equal to what? Sn f of t minus Sn minus 1 f of 0. Okay, here there is no derivative. Then we get the derivative, so Sn minus 2 f of dash 1, okay, 0. So on after that we get it f of f n minus 1 0. Okay, here when we have f n equal to 3 मान लेते हैं 3. After we get f double dash t will be s cube f of t s square f of 0, then s f dash 0 plus s f of 0. That is our Laplace transform. You easily prove it, find it. So that is nothing but I am moving forward on based on the next concept. So here topic for Laplace in derivative of Laplace transform after multiplication of positive integral power. Okay, so write down if ft is write down if ft is the piecewise continuous, piecewise I am writing a piecewise continuous, and Laplace transform f of t is equal to f of s. Okay, so then Laplace transform of t f of t is nothing but minus f of dash equal to 0. That is the concept. So I have to write down the concept and move forward. So what we have to prove it. That means if ft is, we can write it in general. In general, write down the in general. In general, we get Laplace transform of t and f of t. F of t, it is equal to minus d and f of s. Okay, so we will do some question based on this topic. Can I prove it? Okay, proof by yourself. I am giving some hint. So you will use the first. You will use it. Okay, use it. How to use it? We know f dash s is equal to nothing but what? D by ds into f of s. Okay, so now we have to find the derivative of a function. Now d by s f of s equal to what? Okay, this is. Now we have to find the Laplace transform of this. So first we have to find the derivative integral 0 to infinity est f of t. est f of t dt, 0 to infinity. Then we will use the dt. What? By integrated by Leibniz theorem. That give us 0 to infinity d by dt est f of t dt. So you, after integration, you can find it by Leibniz theorem. So I have also uploaded the video on the Leibniz theorem, how to use it. I will give the link in description or button, you can check out. So I have a question. Now evaluate the limit of a function. Find a limit. We have a question. How? Now we have a question. Laplace term of sin a t is what? First we have a find a function. Okay. So I am giving. So how to use it? Okay. So here ft is what? Sin a t. Okay. So Laplace transform of f of t is what? A by s square plus s square. Now here we have a t sin a t. Okay. So that is equal to what? So that is minus f dash s. So we have to differentiate it. So differentiating ds upon s square plus s square upon a. So after differentiation we get s square plus s square into whole square. So that 0 there is nothing. So that will be plus 2s into a. So 2s a upon s square plus s square. That is our derivative. Find the Laplace transform. Find Laplace transform t cube sin a t. Okay. Can you find it? So that is for you. For I have also completed the next video. We will see the another concept of based on the Laplace transform. Thank you for watching me again.